So let's start. Superalloys can be classified as in three types. First is iron based, second is cobalt based, and third is nickel based. So in this lecture we are going to study about iron based superalloys. So all this type of superalloys operates at the temperature greater than 650 degrees Celsius. So the all above superalloys have an FCC austenitic matrix. So they have FCC austenitic matrix, and they all are reinforced by different strengthening mechanism active at high temperature. So let's begin discussing with iron based superalloy. So this superalloy is first, let me write the heading, iron based superalloy. So this superalloy were the first one to be developed. So this superalloy were the first one to be developed. Basically started from austenitic stainless steel. Started from austenitic stainless steel. In this kind of superalloy, we have high iron content and high nickel content. So basically, by high iron content, we mean it contains up to 60% weight of the iron. And have quite simple microstructure with few precipitates. The content of nickel in this alloy is up to 25% by weight. Nickel constitutes 25% by weight because nickel is an austenite stabilizer. This is an austenite stabilizer. Iron has some problem related to oxidation and corrosion. So this type of superalloys has some type of problems related to oxidation and corrosion. Now let's talk about what are the elements which we can find in this kind of superalloy, that is iron based superalloy. In iron based superalloy, typically we have chromium and molybdenum. So these are added to strengthen the alloy by solid solution. So these are added to our superalloy to strengthen the alloy by solid solution. In some cases, molybdenum can be substituted by tungsten, but tungsten is quite expensive. It's quite expensive and dense than the molybdenum. And also we know that the chromium provides resistance to oxidation. Chromium provides resistance to oxidation. So chromium is actually present in this alloy in high amount. Basically we can say it has more than 9% weight. So it is sufficient to form a stable layer during oxidation to provide resistance. Other elements which can be found in this alloy are small elements like carbon, nitrogen, and boron, and so on. So these elements provide solid solution strengthening. So these elements provide solid solution strengthening. So these elements are small, so they will occupy interstitial sites. So these elements will occupy interstitial sites. So we can have addition of titanium, which provides the formation of gamma dash phase. We can add titanium, which provides gamma dash phase. So this is a precipitate coherent with the matrix. So this is a precipitate which is coherent with the matrix. So it provides strengthening with precipitation. So this provides strengthening with precipitation. The same can be done in nickel-based superalloys by adding aluminum, which provides good mechanical strengthening. But in case of iron-based superalloy, aluminum addition is not beneficial, because in the case formation of precipitate, that is alumina precipitate, it will be detrimental for life of component, because their metastable form will change into stable form. And the element that can be formed gamma dash precipitate is nickel. So basically nickel has double effect. It acts as austenite stabilizer and austenite stabilizer, and also it forms gamma dash phase, which is useful for mechanical resistance. In this type of alloy, other second phase can be formed, which is gamma double dash phase. But in this case, we have good mechanical strength, but can go up to low temperature limit. So this specific iron-based superalloy are good enough and possess high strength and high corrosion resistance only in an intermediate temperature range.